Yeah, hi and welcome. I want to talk about electrical motors. First of all, why electrical motors? We need them everywhere. So in every household, in every company, everywhere are electrical motors. And no application today will run without them. So when we use them so much, who is going to care about protection and monitoring of our electrical motors? So what every motor has, you can see here is some basic devices every motor has, but this is just some basic protection of it. If you want to have something more advanced, you could do something like this on the slide, but the problem is you have a lot of sensors, a lot of costs, a lot of effort for installation, so you have also a really poor solution because you have only mechanical faults monitored. So what you really want is the monitoring of all faults that can occur. You also want to have a high detection accuracy and also fast and easy installation of your system. And what this is possible with AI-based monitoring and fault detection based from Jidokai, my startup. And the solution you can see here on the slide looks like this. So you have a simple dashboard, and behind this dashboard is the artificial intelligence, and this intelligence analyzes the electrical currents of your motor and shows the results on the dashboard. So on the upper half of the dashboard, you can see the main thing of it. So is the motor okay or is it not okay? So this is the main point on the button on the left. And the other point is you could also see some additional information on the upper half on the slide, which you can use for speed, current, and so on for some additional analysis if you want to. I have prepared some video to show you this in live. This will show on the next slide. And there you can see how the motor starts, how the motor is running, and how the AI is working on that. So if it's green, the motor is in the healthy state, and if it's getting red, which happens now, then you can see there is a fault. And I will explain again, so it will start from start. First, it's standing, it's gray, then it's starting, it's running, the state is the normal state, and then some fault is implemented on the right. You can see it right now. And this is recognized by the AI, so yeah, it works. And I will carry on with the next slide. Why am I able to do this? So I have researched over 3 years to this topic of fault detection and monitoring of electrical motors. And this is a really big market, but there are only a few researchers on this field. Also, I also worked with industry partners, so I can transfer the research results into a real product. And at last, this is not just PhD project, kind of, it's a real product, it's ready to sell, it's ready for the market. So to show you the process of the startup, it all started with the PhD, as I told you, in 2020. After that, I got last year a finished prototype. And at the moment, I'm in some negotiations with customers, so it's getting into a real product. And for the future, what is planned? It is a pilot project to evaluate the model and also the whole product. So on the next slide, you will see again to the pilot project, because it's mainly about the business model. There are different business models here, like pay-per-engine, pay-per-use, licensing, and so on, but I'm not sure which one to choose. So this is what I want to find out about, and especially with some real partners, which you can see maybe here. So the main big motor manufacturers, I want some contacts to them, want to work together with them. And I also know there are someone here today in the room. So the goal would be to work together with them to evaluate the business model and to start it up. as the summary, I have a validated approach, I have a developed prototype, and I'm now ready for the market.
Thank you, Moritz. It was great. And can you tell us a little bit more about the name Jidokai?
Yeah, it comes from the Japanese word Jidokai, and it's a machine that monitors itself, so all in once.
That's really cool. I like that. Okay, now it's time for the Q&A, and as you say, we have like some Bosch and Mercedes-Benz here. So who wants to start with the questions?
I will start. Thank you for your presentation. I would be a little bit more interested how you would do this, or what are your signals you're using for your AI?
Yeah, as I showed, it's the electrical current, so the three phases of the current. And this is going to the model. The model is trained. It's a little bit more complex. There's like a physical model behind it, physical model who is producing simulation data of the different states, so of the fault and of the healthy state. And with this, it is trained, the AI, and then uses the three phases of the electrical current in the frequency spectrum to analyze the faults. I hope it's clear.
Yeah, but I'm sure there are a lot of more details.
Yeah.
But of course, does it only work for these large motors, or which have a lot of current, of course, and maybe smaller, tiny motors, like we have it in CD players or something like this?
Yeah, so it was mainly based on the, like I said, three-phase induction machines, but it's like a very transferable approach because there is this model in it, so I can transfer the model to another type of motor and then also use the whole like framework, I called it. So it's really transferable from technical side.
Okay, thank you.
Yeah, also a little bit on the algorithmic side. So you detect the faults. You also go a step further and tell or give instruction on how to prevent them?
No, that's not at the moment. It's like, at the moment, it's more like condition monitoring, but it's planned to be like, more predictive maintenance at the end. So I think it is possible with this approach because I see when it's slightly beginning the fault, so I can tell them, okay, you have some bearing faults or so who is going up and have some preventive maintenance then.
Okay, thanks.
Yeah, thank you very much for your presentation. Did I get it right? So you are the founder and you are the team of your startup.
Yes.
Okay. So my experience is that startups fail not because of the technology, the technological idea behind it, but for other reasons. When they start to get into the business, they need customers. What are your thoughts about that? How do you plan for the future, especially if you want to scale?
Yeah. In my opinion, I'm now at the point everything is running, so you can use it. So the next step would be to validate it for several machines, and there would be to partner with some big motor manufacturer and so on, and to get in real use of it. And if then everything is validated good or evaluated, then would be the next step to scale it up with bigger team and so on.
A couple of these engine manufacturers are customers of ours, so SEW, for example. So if I tell them I have this wonderful young gentleman and he has some bright ideas,
yes.
What is it that SEW, for example, does not have what you have? Because they're pretty bright too, and they're measuring a lot of things. And they do measure currents, of course. So what is new? Yeah. What is new? Or what don't they have?
The good one is I just need to measure the electrical current. So the other ones, they measure a lot of stuff like vibration and so on. But this is a lot of effort if you want to do it for a lot of machines. And the electrical current is for every motor there. So you have it and you just have to put the software on it and you have the monitoring of several faults. So it's not just the mechanical, it's mechanical and electrical faults. So you have everything placed.
Very nice. Thank you. Thank you, Moritz. And if you have more questions, we have the break for that, for you too. And thank you for your pitch.
Thank you.
Awesome pitch.